All right, let's wrap up chapter 9, 9-7, probability. So, probability you've seen before a few times. We're going to maybe add a few things. Maybe it's all going to be review. We'll see. All right, so a couple things. Any happening for which the result is uncertain is called the experiment. Okay, and then all of the possible results are the outcomes. Sample space is where we list all the possible outcomes. Okay. And any subcollection of sample space is an event. So we talked about this in last class with the, if you have 6 faculty and then you have 3 students, and we're going to multiply them together. The faculty would be one event, the students would be a separate event. All right, so for instance, when a 6-sided die is tossed, the sample space is the numbers 1 through 6, right? Everything that can happen. The number of things that can happen is going to be our denominator. So for probability of some event E, it's the number of things favorable, the things we want to happen, divided by the number of total events. All right, how many things can happen? All right, so let's start by writing sample space out. Sample space is just everything that can happen. What can happen if we toss a coin? We can either get heads or tails. So that's the whole sample space. What about 2 coins? We could get heads and heads. We could get heads and tails. And then here's the important part. Tails then heads is different than heads and then tails. The order matters here. And then tails, tails. So 4 events there, right? And if you think about this, there are 2 different events that could happen when you first flip the coin. There are 2 events that can happen when you flip the second coin. So there should be 4 distinct events. Right, 3 coins are tossed here. 2 times 2 times 2 is 8, so we should have 8 here. Heads, heads, heads. I'm going to make a little chart. Heads, heads, tails. And then we go heads, tails, heads, heads, tails, tails. And then the tails column. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. I'd keep that chart. That's going to come up again shortly, but for now, see if you can figure out the sample space for a coin and then a 6-sided die flipped up and tossed. All right, so we've already said this. The probability of an event are the number favorable over the number total. That number needs to be between 0 and 1. There needs to be fewer things favorable than there are total, right? And if your probability is 0, it cannot occur. If it's 1, it must occur, and 50% equally likely to occur as it is unlikely to occur. All right, so let's flip 2 coins and find the probability that both land heads up. So, how many ways are there to get 2 heads up? There's only one way. How many different ways are there to toss 2 coins? 2 times 2 heads or tails for 2 distinct flips. So 1/4. So we have a 0.25 or 25% chance. Now I write all these 3 because all 3 of these are acceptable answers. Fraction, decimal, or percentage. Anything will suffice. For B, how many aces are there in a deck of cards? There's 4. And come back, pen. There you go. There's 4, and there are 52 cards total. So you have a 1 out of 13 chance. And what is that as a decimal? Calculator. 1 out of 13 is, so 7.69%, or 0.0769. You're up. Oh, there's that again. You're up. Find the probability of getting exactly 1 tail. All right, 2 6-sided dice are tossed. What's the probability? The total is 7. Let's figure out all the ways to add up to 7. A 1 and a 6, a 2 and a 5, a 3 and a 4. 4 and a 3 is different than 3 and 4, so we got to go all the way through. So there are 6 ways out of, how many different possibilities are there? Well, if you roll the dice first, there's 6 ways there. And there's 6 numbers that can come up on the second die. So we have a 6 out of 36 chance, which is 1/6. Okay, so you have a 1 out of 6 chance. That's the probability of getting a 7, which actually is the most likely outcome using 2 dice. See if you can figure out the probability the sum is 6. Alright, 12-sided dice, as shown in the figure that's in the book but not here, can be constructed in a dodecahedron, so that we have 1 through 6 showing up twice on each die. Prove that the 12-sided dice has the same odds as a 6-sided dice is what we're looking for. Alright, so let's think about this. On a 6-sided die, what's the probability of rolling a 1? 1 out of 6. On a 12-sided die, what's the probability of rolling a 1? There's 2 1s on that die, and there's 12 sides. So 1 out of 6 as well. And that would repeat for all the other options as well. There's 2 2s out of 12, so 1/6 as well. Go all the way through. Alright, so you throw 2 6-sided dice and find that the sum is less than 11. Alright, in Arizona, they have a lottery game where a player chooses 6 different numbers from 1 to 44, and if you match those 6 numbers in any order, you're going to win the prize. What's the probability? Okay, so in this situation, we're going to use what we had in 9-6, combinations and permutations. We are choosing from 44 numbers. We're picking 6 of them. And the order does not matter. It says that right here. So if you remember back, that's a combinations problem. So 44C6. That's how many different possible lottery tickets there are. How many are we buying? We're buying 1 of them. So we have a 1 out of 44C6 chance of winning this lottery. And what is 44C6? You have a 1 in 7,059,052nd chance. What is that? We'll times it by 100 to get percent. And it's still, you have a 0.00014% chance. Not too likely you're winning the lottery. Alright, different thought process. Think about this bag of marbles. Figure out if you draw 2, both of them are red. Alright, now we're going to add things up here. So, number of colleges in various regions listed here. One institution is picked from random. What's the probability that it's in one of the 3 southern regions? How many southern region colleges and universities are there? 406, 276, 738. If we put those together, we've got what do we got here? 16, 22, 12, 8, 10, 14, 14, 22. And then we need to find out how many schools there are total. So we'll add the rest, starting with 1422, 629. Just going to cross them off so I make sure I get them all. Does it list somewhere how many there are? That'd be helpful. I guess not. 660, 450, 303, and 583. Add them up. 2 plus 9 is 11, 15, 18, 21, 2, 4, 6, 12, 18, 23, 31, 7, 13, 15, 21, 25, 33, so 43, 11. So the probability of picking a southern school is 1422 out of 43. 11. That's not a very nice fraction, so we're probably going to want to talk about this in terms of a percent. Let's divide 1422 divided by 4311. 32.98%. Same type of thinking. Let's see if you can answer these questions on 43. All right, mutually exclusive events. So this is an and type of thing. If you have a formula where it's I want something and something else, we're going to add their individual probabilities. But mutually exclusive means don't repeat numbers. If something can happen in both events, you only count them once. Right? So if you counted them in both places, you have to subtract how many repeats you have. That's what this formula is saying here. So if we have a card selected from a standard 52 card deck, what is the probability we either get a heart or a face card? How many hearts are there? There's 13. Or means we're going to add up. How many face cards are there? Face card would be Jack, Queen, King, and Ace. So 4 out of 4 sets. So that's 16 out of 52. Right? However, there are 4 cards that are both hearts and face cards. So we need to subtract out the ones that we've counted in both categories. So that's why we minus the 4. All right, so 13 plus 16 is 29, minus 4 is 25 50-seconds. You have a 25 out of 52 chance of getting a heart or a face card. I guess they're not considering aces to be face cards. I guess that's true, huh? Aces wouldn't be face cards, so this is going to be a 13. And then this would be a 3. So 26 minus 3, so 23 out of 52 repeats. Moving on. Here we go. Answer 57 based on the standard 52 card playing deck. All right, so we have a chart here. If an employee is chosen at random, what is the probability that the employee has 4 or fewer years of service or 9 or fewer years of service? So we would need to add up the whole list here. Let's just do that real quick. 157 plus 89 plus 74, 63, 42, 38, 37, 21, and 8. So there's 529 employees. How many have 4 or fewer years of service? 157 of them. And 9 or fewer. That would be both of these combined, which is going to be 246. And that's it. That's your probability of an employee being chosen from random from those subgroups. Okay. Okay, independent events. First one thing happens, then another thing happens. Something and something else is a multiplying problem. So or means add, and means multiply. So we're going to pull 3 numbers from 1 to 20 at random. What's the probability that all 3 numbers are less than or equal to 5? Okay, so the first number, there are 5 out of 20 numbers we like. The second, there are 5 out of 20 numbers we like. And the third one, there are 5 out of 20 numbers that we like. We want 3 numbers, so that's first and second and third numbers. So we would have 125 out of 8,000. Multiplying those together. Okay, so and means multiply. Make that work for problem 61. All right, so approximately 13% of the adult population gets their news off the internet in 2009. I'm sure it's higher than that now. If you chose 10 people at random, what's the probability that all 10 got their news from the internet? So the first person has a 13% chance. So does the second person. So does the third person. I want the first and the second and the third and the fourth and the fifth. We're going to multiply them all together. That's 0.13 to the 10th. Okay, so that's going to be a very small number. 0.13 to the 10th. So 8 zeros and then a 1. That's a small percentage of the population, or a small percentage of the time we would get 10 people in a row. Hard to do that. Answer 63. All right, the complement. Probabilities need to add up to 100%. So if the probability of winning a game is a quarter, the probability of losing a game is 3/4. The complement is 1 minus the opposite of it. Okay, so that's useful in problems like this where we want, so 1 out of every 1,000 units it produces is going to be faulty. What's the probability that if you order 200, you'll have 1 or more faulty units? Well, that's really hard to figure out if you tried to figure out, because maybe there's 1 faulty, or 2 faulty, or 3, or 4. We'd have to add them up. The better way of solving this is none are faulty. And then we use the complement to figure out the opposite. So what's the probability that none are faulty? It says that there's a faulty one 1 out of every 1,000, which that means for every 1,000, 999 of them are not going to be faulty. Okay? So you have a 999 over 1,000 chance of having a good unit shipped to you, a good machine. If we have 200 of those coming to us, we're going to raise that to the 200th. So there's a 99 over 1,000 to the 200th chance that none are faulty. Let's figure out what that is. 999 over 1,000 to the 200th. There's an 81.86% chance that none are faulty. What's the probability that at least 1 is faulty then is 100% minus the 81.86. So 18.14% chance that at least 1 of those units is going to be defective if you're ordering 200 of them. Last one here, see if you can answer 65. You're all done. Questions, we'll go over them in class.